welcome back, mindsetters. Obviously, this is grade 11. Not obvious. This is grade 11 physical science. I hope you guys are enjoying the show. We have reached the point where you guys must send in your questions. Please do, because we are looking forward to them. And there are questions. Don't think that I've disregarded them. Tracy has seen them, and she will try answer them for you in this section. But if you have more, please don't fear sending them to us. That's what we're here for. Over to you, Tracy.
Thank you, Kathleen. Well, like you said, I'll try. Some of them I might not be able to do. Okay, now, why are we doing this whole thing with the lithosphere? Other than to give you lots and lots of stuff to learn. Because we need to look at our energy resources which come from the lithosphere. Okay, so the things that we, besides the minerals, besides the gold and the iron and all of those sort of things, what else do we get from our lithosphere, which is really, really important? And the first one is the most obvious, which is coal. I'm hoping most of you realize this is where a lot of energy is going at the moment, because we need to find alternatives to our coal supply, because coal is running out. South Africa is the only, and this actually surprised me when I realized, is only the world's 6th largest coal producer. Okay, only number 6, which is not a bad thing, but we are going to run out. And depending on the documentation, depending on where you look, some people go, it could be anything between 50 and 200 years before we run out of coal. If it's in 50 years, that's within our lifetime. That is scary, grade 11s, because then we need to find something else to replace it. And in fact, 83% of South Africa's coal production happens in Mpumalanga. Okay? We know, I'm hoping you all realize, you know that coal comes from the decomposition of organic material, trees essentially. They get pushed, they die, they get pushed under the ground. Over time, they get buried under lots of heat and pressure. That turns them into coal, which eventually, if they're left there long enough, becomes diamonds, which is also why South Africa is such a diamond-rich country, because we have a lot of coal, okay? Now, we know that Eskom, our wonderful electricity supplying company, they produce most of the energy in this country, though not all of it. We do have some municipalities that are independent producers, but they are very reliant on coal. We are looking at other ways of producing electricity, but coal's our main one. Issues with coal, they produce greenhouse gases. So they produce, when we burn coal, we get things like sulfur dioxide coming off, carbon dioxide, we get nitrogen oxides as well. All of those produce our greenhouse gases. They also contribute to acid rain, okay? We also find coal in Limpopo, the Free State, and Natal. Sorry, the Cape, you guys didn't get very much of that at all. But you got diamonds. I mean, you got Kimberley in the Big Hole, which is great, okay? What's the other one? Uranium. Now, this I found quite interesting because I wasn't aware of how much uranium we actually produce, but we do actually mine a lot of uranium, which you would think we would have more nuclear power stations. Remember, uranium is radioactive, and uranium doesn't burn. We create a nuclear reaction with it, which means we split the atom with it, and that splitting of the atom, which is nuclear fission, gives us lots and lots of energy, okay? We get it as a byproduct, so we don't mine it specifically. It's a byproduct from our gold mines, which is quite scary, which are mainly in the Witwatersrand, which is where we live, as well as from some of our copper mines in Palabora. Okay, now, what's the problem with uranium? Well, it's radioactive. So when we look at our nuclear power stations, the big issue, and this is what people really struggle with them, is how do we get rid of our nuclear waste? Because it takes so long to decompose, and it is so bad for us. Remember a couple of years ago when Japan had that horrible, horrible earthquake, and then they were flooding, and there was that huge worry about one of their nuclear power stations going critical, which would then be worse than Chernobyl, which was about 30 years ago in Russia. And that was just an unbelievable tragedy, and people still can't live in that area. It is still radioactive, and it's still going to be another 20 to 30 years before people can move back to Chernobyl and start growing crops that won't have radioactive side effects to it. So nuclear can be quite interesting. Oil is the next thing, which if you drive a car, you know that the amount of money we spend on our petrol is very determined by the oil price. And we often get told that the oil price is going to increase because there has been an issue with the oil price internationally. A lot of wars are fought over oil, unfortunately. We are not a very oil-rich country. We have to import a lot of oil. The Middle East is where most of the oil is. Okay. We do, though, have a way of refining coal into our oils. Durban, Cape Town, and Sasolburg. Remember, Sasolburg was named after Sasol, and Sasol is the South African Coal, Oil, and Gas Corporation. Sasol is an amazing corporation for us. Sasol has developed many years ago how to produce petrol from coal. It's great. It actually still gives us some of the cheapest petrol in the world. So before we start moaning about the petrol price, and I know it hurts every time I put petrol in my car, I still think, you know what, I'm paying less than they do in the UK. So I'm quite happy with that. Oil is organic, just like coal. We have oil rigs out on the coast. Most of our oil is offshore. We get a lot of natural gas with it. Okay. Oil happens in the sedimentary layers, and it's got to be mined. It's a very specific way of mining. Okay, lots there. Katlego,
Yes.
I'm definitely ready for some questions.
Okay,
now.
let's do some questions.
Okay.
We have some jokes, so that's awesome.
Okay.
But we'll tell you the jokes afterwards.
Okay.
So there's a question that asks by Chifiwa. She asks, uranium is usually used in nuclear reactions. What makes it radioactive? Can it be man-made, or is it mined? As if it is, where is it mined? And if it is, where is it mined?
Okay. It's definitely not man-made. It's a natural element. Okay. It's a byproduct of our gold mining in the Witwatersrand, like I said earlier, and our copper mining in Palabora. What makes it radioactive is a difficult question. It's got to do with its structure of the atom. Okay, and it's one of those, there's a whole bunch of radioactive elements that just are, and what makes it radioactive is that it decomposes very, very readily, and as it decomposes, it shoots off energy particles, and those energy particles interfere with, in particular, human cells and that sort of thing, so that makes it very, very dangerous because it breaks them down. Why? Because that's just the way it is. Unfortunately, we're not really sure, and we can't really understand why. But all the man-made elements that we have, uranium's not one of them, all the man-made elements after 102 on the periodic table are all radioactive because we can't keep them. They break down very, 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 very quickly.
Okay.
Yeah.
Okay, so by a question from Takalani Paswana.
Mm-hmm.
He asks, why distribution of mineral is not uniform? Why some areas have higher deposits of certain minerals than others?
That I'm not 100% sure of. But Takalani, you remember the Earth is very, very old. And the theory behind where we get our continents and continental shift is at one stage, all the continents were one huge big continent. And remember, the birth of the Earth and the birth of the continents wasn't this nice, sedate little process. It was extremely violent, okay, because you had all the earthquakes, we had lots of earthquakes, we had lots of volcanoes, all of that sort of thing. And that's what's led to everything being distributed where it is. I mean, even with our animals, I think countries like Australia have their own unique brand of animals that you only find in Australia. Who knows why, but...
Because they're weird.
Well, they are weird, they're Australian, because that's just the way it is. But it's just because of the way the Earth was formed. And unfortunately, there's no easy answer to that, and I can't say to you, well, you know. I think, personally, that was the hand of God going, I want lots there. I don't know. Yeah, that's just me.
And there's another one by Anele. She asks, does mining by any chance affect the mantle, I think she meant, leading to volcano eruptions?
Okay, it shouldn't, sweetie. If we look at that's actually quite a good question. If we go back to my original picture, if you're mining into the mantle, you are very, 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 very deep. Most mines will only go as far as 1, maybe 2 kilometers below the surface of the Earth. Simply because the pressure's too much for humans to go down there, and it is so hot. Mining becomes very, very dangerous. If we start looking at if we're mining into the mantle, like really, really mining into the mantle, we have a problem. Mining shouldn't interrupt with volcanoes. It shouldn't disrupt the natural processes, but who knows? I think we've done so much damage along the way to our planet. Unfortunately, we only seen the consequences now. But offhand, I would say to you, no. Mining shouldn't cause volcano eruptions. It shouldn't cause earthquakes. Though if you live in Joburg, you often feel earth tremors, and it's not the earth. It's actually them blasting in the mines. I grew up on the East Rand on a mine in a mining town, and you just learn to live with it. You just you feel the earth tremor. They're blasting again. Unfortunately those mines have closed down, but you just get used to it. You don't even think twice because that's just the way it is. We shouldn't be causing that much damage, but who knows?
Happens.
I'm not sure there are any mines close to volcanoes that I know of, but
Maybe.
there's enough sci-fi movies out there.
Yeah.
Who knows? Yeah.
And there's one by Karabo. Karabo asks, what makes up the Earth's crust?
The crust is all the minerals, okay? It's what we were talking about earlier. The Earth's crust is all the elements that we find in the Earth's crust, like oxygen, potassium, sodium, silicon, all of those sort of things. Most of the time we see it as silicon dioxide, we see it as sand, okay? And our mud and our rocks and all of those sort of things combined together, that makes up our crust. Once we start getting to the mantle, particularly not the upper mantle, the middle mantle, this middle part, that's our molten. That's where we get our molten rock, the magma. Okay, that's where everything starts to just mush into this one big liquid hot thing that then gets spewed out of our active volcanoes. Luckily, we don't have any, so yeah.
Okay, and then there is one other one.
Okay.
Just need to set my eyes on it. Okay, there you go. Buitumelo asks, he says, Tracy, I don't understand the difference between minerals, rocks, and ores.
Okay.
So please may you just go briefly.
No, that's cool. Okay. Minerals is a mineral refers to the actual compound, refers to the actual element, okay? So your mineral is potassium, sodium, oxygen, or potassium oxide, sodium oxide. It's the actual element. It's the chemical compound. Rocks is when I take a whole bunch of those minerals and push them together into one space. So we have a whole bunch of minerals that we've now got these lots of molecules together, we make them into a rock. When that rock is found and we have lots of them together of the same type, we now have an ore, and that ore becomes something we can mine. Okay, so minerals is the element, rocks are almost like your mixture of minerals, and then your ore is a whole bunch of rock together. Basically.
Okay.
Yeah.
And there's another one
Okay,
by...
we've got like 20 seconds. There we go.
No, well, do you want
We
to
can
get
do
some
this.
quickly? Okay, let me read like in 5 seconds. Tracy, why is it that we can't get 100% pure gold and is diamond the same?
We can't, diamonds, it is definitely 100% pure. If you
Okay.
get that, the quality determines the carat. You can get 100% pure gold, it's just a bit useless because it's soft. Far, far too soft for us to use. So we have to mix it with something to make it harder.
Okay, awesome. Well, I don't know how much time we have left.
I think we've run out of time, actually.
Okay, so I think that's okay. And of course, guys, as you guys have noticed, we have reached our 15,000 likes. It's awesome, and I know there's a lot of excitement on the page, and I'm loving it. And thank you so much for the jokes as well. I've been laughing here by myself, giggling, so that you guys don't hear, and Tracy doesn't hear the disruption of the jokes. So thank you for the jokes, and thank you for the 15,000 likes. Thank you to every one of you that also joined us today. And once again, thank you to Liberty. We all know Liberty is awesome. And of course, thank you to our awesome Tracy. It was really an awesome, awesome lesson, and I hope you guys learned more and learned extra. Call all your grade 12 friends and sisters and brothers. Tell them that we are up next with physical science for them. See you next week, guys. Bye.